This one is, it looks funky because it's got all these e to the x's and fractions, and like when I have a fraction, I look for ln, but it doesn't work here. So there's a trick that I can use here. I can actually take care of this guy and move it to the top of the fraction. So I'm going to rewrite this as integral. If I move it to the top of the fraction, then it becomes e to the negative x times what all that stuff in the top was. So 4e to the 2x plus 3e to the x minus 1. Now what I can do is distribute this into each of these pieces. And as I multiply, I use kind of rules about multiplying exponents. So this is the same as the integral of, well, the first product is 4. And then when I get to e to the negative x, or sorry, e to the negative x times e to the 2x, well, that's the same as e, just like x squared times x to the 7th is x to the 9th. This is the same as e to the negative x. I add to get that 9, right? So I add these guys to get plus 2x like this, which then I can add that pretty easily. Just gives me e to the x. And that's what I'm going to use for all these. So that first one is 4 times e to the x, as I just showed over there on the right. And then plus just straight up 3, that e to the this right here. They cancel each other. The e to the x and the e to the negative x, and then minus e to the negative x, and this has a dx and a dx and dx. So now I just integrate the individual pieces, and it's not really that bad. The derivative of e to the x is e to the x, so when I integrate e to the x, I also get e to the x. So my first part is just 4 e to the x. Then it's the integral of 3. Well, it's 3 times x. And then integral of e to the negative x is e to the negative x. Now I just have to work out my coefficient so that I will get this minus sign out. What would I need to put right here so that when I derive it up to that, I get this minus? Well, I would need it to be positive. And then I get my plus c. And that's all for that one.